Lesson 10.3 is going to be all about the properties of logarithms. Now before we go on to true and false questions, let's just look exactly at what some of these properties are. So if we have log base a of u times v, in this case here, we can break it apart into two logarithms added together, as long as they have the same base. So it would be log base a of u plus log base a of v. So essentially this multiplication here breaks apart into addition. Now over here, similar process. If we have log base a of u divided by v, over there we had multiplication and changing into addition. Here we'll have log base a of u minus, so we're doing subtraction, log base a of v. So multiplication went with addition, and division goes with subtraction. Now this last, another piece here, if we have log base a of u to the c power, we can take that power, that c, and actually bring it out front and say c times the amount log base a of u. So it'll be helpful in converting from one thing to another here. But so essentially it's saying c times this whole amount would be the same as log base a of u to that c power. Now this one over here, log base a of u plus v, there are actually no special properties. There's nothing, no powers here. So whereas this one over here might be the Hulk, this one maybe was Superman, this one was, I don't know, Wonder Woman or something. This is essentially Spider-Man's aunt. She's got no special powers. There's nothing cool about this. You literally would have to add u plus v together and then just take whatever the log base a of that value. You have to find it out. So nothing special there. So going back to our properties then, and these true-false statements, is the log of 2 times 5 equal to the log of 2 times the log of 5. Now, quick little lesson here. This is going to come up tomorrow when we're talking about common logs. If we just say log of 2, that's a common log. So it's actually technically log base 10 of 2. So if they don't write it, they just kind of mean, they imply base 10. So this is going to be log base 10 of 2 times 5 equals log base 10 of 2 times log base 10 of 5. Well, that one is not going to be true. This one does not hold up if you were to plug that into your calculator. So let's try log base 10 again. All of these are essentially base 10. Log base 10 of 10, is it the same as log base 10 of 2 plus log base 10 of 5? Well, yes, this one actually is true. This one works. And again, if you wanted to go through and check that on your calculator, you totally could. That one will work out. If we take log, again, technically base 10 of 100 plus 10, is that going to be log base 10 of 100 plus log base 10 of 10? In this case, no, this one does not check out. That does not follow any of our properties at all. And this one here, if we have log of 10 to the third power, so essentially that's like saying log of 10 to the 1, 2, 3 is the log of 1,000 equal to the log of 10 to the 3. Well, we know log base 10 of 10 is 1, right? Because 10 to the 1 would be 10. And to the third power, well, this is essentially log base 10 then. Well, log base 10 of 1,000 is actually 3. So what it's saying here is 3 equals 1 to the third. Well, we know this one does not work then. So if we come up to the other side here, log base 10 of 100 over 10. So again, 100 over 10, we could just call this 10. Is the log base 10 of 10 equal to the log base 100 over the log base 10 of 10? Do that on your calculators. It does not work. Log base 10 of 100 divided by 10 equals log base 10 of 100 minus log base 10 of 10. Well, again, our properties say that that one does fit. That is pretty much exactly that division to multiplication version. That property does fit in this case. Which then means if we have this side being the same, but it has a different answer over here, probably, whoops, wanted red, that one does not hold up. If you plug that into the calculator, it will not work. How about though if we have log base 10 of 10 to the third power equals 3 times log base 10 of 10? Well, remember from our properties, that one does work. That one is totally fine. So we can use those properties to solve different problems like this. And there again were those properties. So let's move on to trying to solve some of these. Now, if all the terms do not have logs, then reduce the equation down to a single logarithm and put it into exponential form to finish solving. Now, if that's a little bit confusing, I'll show you how that works here. So in this first example, if we have log base 2 of x plus log base 2 of x plus 2 equaling 3, well, notice how they both have the same log base 2 on this side. And they have this add in between them, the addition. So we know from our properties, we can change that to log base 2 of x times x plus 2. So we're taking the 2 that we had and just multiplying them together. And then now saying that that equals 3. So we've simplified it a little bit to get to here. Now that we have just one logarithm that we're working with, we can change that to an exponential form. And we would then say, we'll leave this on this side, x times x plus 2 equals 2 to the third power. And again, that's just simply going from a logarithmic form to an exponential form. We know exactly what this means. We didn't do anything too extreme here. Now all we have to do is distribute and simplify, or should I say, and solve. So x times x is x squared, x times 2 is plus 2x, equals 2 times 2 is 4, times another 2 is 8. And all we have to do then is solve for x. So in this case we would say, if we subtract 8 from both sides, x squared plus 2x minus 8 equals 0. Give us a little more room to work down here. So we'll solve by factoring in this case. X, we'll do x minus 2 and x plus 4 are the factors, equal to 0. So we know then that x has to equal either positive 2 or negative 4. Those are the only possible answers for x. But if we look back at our original equation, we're looking at two different logarithms. And actually in both cases, if we were to plug in negative 4, we would have a negative here and a negative here. We'd have log base 2 of negative 4 and log base 2 of negative 2. And those will not work. We can't take log base 2 of a negative number. So this 4 doesn't work. So in the end, our only answer is x equals 2. So make sure we always check our answers. So same thing here. What we need to do is simplify down into just one logarithm. So again, we have 2 log base 2's with an addition in between them. So we can just simplify that down into log base 2 of a multiplication problem. X times x minus 6. And that equals 4. Then we want to change that into an exponent instead of the logarithmic form. So we would do x minus 6 equals 2 to the 4th power. Now from here, we will distribute, get x squared minus 6x equals, and just solve for 2 to the 4th. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. Then from here, subtract 16 from both sides so we can solve for x. Oops. Minus 16 equals 0. Solve by factoring again, and we get x minus 8, x plus 2 equals 0. So it looks like our solutions would be x equals 8 or negative 2. But again, coming back up here, if we were to plug in negative 2, here we'd have log base 2 of negative 2. Here we would have log base 2 of negative 8. In both cases, negative numbers, so we can't use that value. Our 8 checks out in both places, though. So we would say then it is x is 8 in both cases.